Hello and greetings, everyone. Welcome to our Cloud Lunch and Learn session today. I'm happy to have you here, Andy. We have a guest speaker. He's a Microsoft MVP, and he has been involved with data engineering and data services in Microsoft technologies. Today's session, as you may know, it's about Microsoft Fabric warehouses for database administrator, and as it sounds from the title, it's going to be focused on Microsoft Fabric warehouses. However, it will have this twist of DBA, right? Database administrator, where you want to learn things from that perspective, from that role. And Andy is here to present. Andy, welcome from United Kingdom. He's joining close from the London area. So how are you doing today? How is going?
Hello there. Yes, I'm doing very well. Very well, thank you very much. It's a little grey and cold outside, but
Yeah.
that's the UK this time of year. But I hope you're well as well.
Yeah. I mean, we had just election last evening, so things are still going on here in the United States. So
Yeah.
it's a
You'll
big
probably
event
need a
for the
lot of
world.
sleep later on.
Yeah, it's I think the world was watching. But anyway, new day start with the new challenges. So we are here, but I'm happy that we start with Cloud Lunch and Learn session here in States. At least on the East Coast where I am now. Welcome to the studio again. Andy is again. Is there anything else you want to speak about your session, about yourself before we kick off, or you want to kick off with the slides? What's your preference here?
Yeah, we'll kick off so I
All
can
right, let's
just
bring
go
it.
through all about me very
All
briefly as
right.
we go in. But
Okay. So please go ahead, Andy. Start your presentation. I'll be in the background and bring questions from time to time whenever I see something. Thank you.
amazing. Thank you very much. So thank you for setting up the Cloud Lunch and Learn session. I've been at Cloud Lunch and Learn before, speaking about Synapse and serverless pools and warehousing. So if anyone's seen any of those sessions before, essentially that's the flavor that I have really is around warehousing. Now we're going to go into Fabric warehouses. Now I know it says the database administrator. What I should do is also put in brackets and for anyone else who cares about looking after a warehouse service within Fabric as well. And I'll explain what I mean by that as we go through the session. Okay, so my name's Andy Cutler, and I'm an independent contractor and consultant around the Azure data platform, Microsoft BI, and increasingly Fabric. So Fabric is now being generally available for well over a year. So that is starting to gain a lot of momentum because of the value that it can bring. I mostly blog at serverlesssql.com. If you scan the QR code, that'll take you to Linktree, and that has other social sites on there as well, such as my YouTube channel, my social media accounts, and my LinkedIn as well. So feel free to contact me on any of those channels. So we're going to go through a few areas of interest in terms of looking after the Fabric warehouse service. Now, some of these areas you might be hands on with because you can be, other areas less so because you don't have any other option. It's just automated. But it's good to understand those areas so that you know what they are. So we're going to have a look at the compute itself. How do we connect to Fabric warehouses? Is this some completely different technology that we need a completely different set of tools to connect? How are we storing data? And do we have to come with any considerations about how to manage that storage? What metadata and DMVs, data management views, do we have? All good database platforms have the ability to look at metadata and to have a look at what's going on under the hood. This is a SQL system. We have transactional capabilities, ACID, atomicity, consistency, isolation, and durability. But there are some caveats. We'll look at that. Security. This is probably one of the things that I see the most on forums around the warehouse service in Fabric. We'll look at that. How do we monitor? That's going to include costs as well. What do we do when things go wrong? What options do we have when we have to ensure that the business is able to continue to load and report data? What happens then? What's the source control and CI/CD story? That's an interesting topic as well. Vital for any workloads that actually make it into a production environment, right? How are you going to make changes? And some very basic performance tuning tips. I don't want to go into the performance tuning too much because that's a session in itself, but there are some basic considerations due to the underlying technology, especially the storage technology, that you can take into account to increase some efficiencies there in the performance. So I'm going to set the scene. It's a little cheeky, but it's a Friday. It's a late afternoon. And someone in the business says, "Hey, we've just got a Fabric warehouse." And you, as the DBA slash platform administrator slash person that we've just pointed at and said, you've got to look after that system, has said, "Well, we've got a warehouse." Obviously, you're just about to leave the office, so you're not too fussed about looking at work messages as you're about to leave. So you ask them, "Well, what's a Fabric warehouse?" "Hey, it's going to solve all our data integration and reporting problems. No problem at all. We're going to implement it. Everything's going to be fine." So, of course, you use the upside down smiley face emoji to denote, "Oh, okay. I tell you what, I'm going to go and have a look and see what a Fabric warehouse is. And more importantly, what am I going to do to look after it?" So, very briefly, with Fabric, Microsoft have added significant functionality to a Power BI tenancy. They've added in data engineering workloads with Spark. So you can write Python and load data. It's brought in Data Factory, the data integration technology that enables you to connect to all sorts of different services, build metadata driven pipelines and frameworks, and load your data in. There's real time streaming there. It is a large product. And we're purchasing capacity, a simplification of how compute works. It has its own set of complications as well in terms of pricing and understanding usage. We'll get onto that into the monitoring section. However, this is a SaaS product, it's software as a service. We have a lot of control abstracted away from us. The most control you can have in Fabric is via Spark, because you've got lots of configurations available within Spark. You can bring libraries, the full breadth and depth of what Spark offers. The warehouse service, on the other hand, is a little more closed off. But some of the technology is being underpinned by open source, which is the Delta Lake format and Parquet. Ultimately, the offering, i.e., why would you want to use Fabric, is that it's this all in one platform. It enables you to do an end to end data platform solution without having to do the heavy lifting and connectivity of lots of other different services. So, if I compare it to Azure, you're having to put together lots and lots of different discrete services with all their idiosyncrasies and connection properties. So, what Fabric allows us to do, get our source data, we can ingest it, we can load it. That's via batch, that's via real time streaming. We can transform that data, process it, cleanse it, enrich it. We can land it in storage. We've got different storage methods depending on skill set and scenarios and use cases, all contained within the Fabric ecosystem. And what do we want to do with that data? Well, we want to build machine learning models. We want to understand what's going on with that data. Fabric exposes AI components like Copilot, like AI skills that allow us to plug into that data and find out what's going on. And we can report. We can build our Power BI semantic models. We've got new connectivity technology that enables faster reporting. And this is all in Fabric. This is ultimately the benefit of Fabric, all in one. Now, with that Fabric model, we're on software as a service, which essentially means that Microsoft or whoever, AWS, Google, whatever services they're providing, if it's a software as a service model, you're abstracting or you're having a lot of that control taken away from you, which is a good and a bad thing. So, for example, you don't have to worry about hardware. You don't even have to worry about operating systems. You don't even have to worry about installing and configuring software. It's all abstracted away from you. You do have to care about your data and about security. So it doesn't matter that Microsoft are looking after all the compute, all the back end. You still need to make sure that your security is what your organization needs based on your data. So, in terms of the Fabric warehouse service itself, so we're going to dive into the warehouse service now. Right. So, I'll leave that diagram on the right just for a minute while we dive in. Ultimately, it is a T-SQL service. So, if you're used to on-premises SQL Server, if you're used to Azure SQL Database, if you're used to Synapse dedicated SQL pools, ultimately, with a little tweaking of your knowledge, you should be comfortable working with the Fabric warehouse, right? That auto scale is because you don't have any control about the compute under the scenes. You have overall control over the capacity and the size of the capacity, but other services are using that capacity as well. Essentially, on the right hand side, we're going to get a workload request. It could be an insert statement, a select statement, and this DQP, this distributed query processor, is going to take that query and see how much compute do I need to run this query as quick and as efficiently as I can. So there could be any number of compute pools that get spun up to service that request, and then they vanish. So it's very much spin up on demand a set of compute nodes to do that T-SQL statement and then switch them off again or reuse them if another statement comes in, right? You've got no control over how many compute nodes are used. But we've got our familiar constructs. Essentially, a warehouse is a table. A warehouse is a database. Hold that thought when we look at it later on in another slide. But we've got tables and we've got columns, right? Familiar T-SQL and relational database constructs. And it does separate compute and storage. So Microsoft are now using the Parquet file format to store data. And that is they're using Delta Lake as the intermediate service between the Fabric engine, the Polaris engine, and Parquet file format. So essentially, Delta allows transactional consistency. Delta is the intermediate layer between the engine and between the storage. And it'll make sure that your data is maintained and is consistent when it's being read and more importantly when it's being written. It reduces contention and it reduces any chances of corruption happening, which used to happen before we had these intermediate engines. Other engines are available. We have Iceberg that Snowflake uses. Now, in terms of sitting in an architecture, the warehouse is very much on the right hand side of your typical data flow diagram. It sits closer to the reporting. So think star schema, dimensional modeling, think facts, think dimensions. It's not really meant for raw data. I'd argue it's not even really meant for cleansed data. It's for modeled data. And if you think of what is now a commonly used term and pattern, the medallion architecture. I'm not going to go into the ins and outs of what all of the zones mean. There can be many of these zones, there can be as few or as many as you like. Okay, that's a discussion for a different day. Ultimately, the warehouse sits in the gold zone, the layer in which you've modeled your data. So you could have fact tables, you could have aggregate tables, you could have dimensions. That's where it's going to sit. Now, we're about quarter of the way through. It's all in the cloud. That's it. It's all magic. We don't have to do anything. We can just provision a warehouse service. Job done. Except not quite. So, in terms of the compute, we still need to provision that compute. We still need to be able to create a fabric capacity. Somebody needs access. Somebody needs the permissions to be able to go into Azure and provision a fabric capacity. Who's that? An enterprise architect, a DBA perhaps, a DevOps engineer? Then someone's going to have permissions to be able to assign workspaces in Power BI and Fabric to a Fabric capacity. So somebody needs permissions to be able to do that. Ultimately, on the left-hand side, we've got our Power BI, our Fabric workspaces. We need to connect those workspaces to a Fabric capacity in the workspace options. And we can choose whichever capacity we have access to. A Fabric tenancy can have multiple capacities. We may be region bound in terms of data. Well, hey, I can create a Fabric capacity in America, in Europe, in Japan, and the data loaded into that workspace is going to sit there. So,
Hi,
yes,
Andy.
so
Before you continue with capacity planning, there's a question on the studio I'll bring to the screen. So basically, Oliver is asking, what is the easiest way to automate the restarting of a paused capacity and vice versa? And before that, you basically was asking about automation to restart a pause capacity.
yes, I
Um,
did have a little look
yeah,
down, and
no,
actually,
that's fine. And
Anthony
go ahead.
is
What
pretty,
would be, yeah, and
pretty,
it was a what? Go ahead, please. Yeah.
yeah, it's pretty much answered
Mm-hmm.
what I would think in terms of there's nothing within Fabric itself
Mm-hmm.
that allows you to switch off the capacity when it's not being used. There is no auto shutdown, so you have to instantiate that from outside of Fabric. So, for
Okay.
example, I mean, Anthony's mentioned Logic Apps and Power Automate. Yes, there are blog posts out there that tell you how you can use tools like Logic Apps and tools like Power Automate to pause and resume a capacity. What I would
Okay.
say is that you have to look at the pricing. So,
Mm-hmm.
at the moment, if you're pausing a capacity, excuse me, you would have to be pausing that capacity at least 40% of the time, because reserved pricing gives you 40% off the pay as you go anyway. So
Right.
to get those economies of scale, if you were pausing a capacity, it would have to be paused more than 40% for you to actually realize the benefits. Resizing the capacity comes with challenges dependent on your workloads, right? Again, I see it quite often on forums where people are saying, I'm running a certain sized capacity, let's say an F8, and then I'm dropping the size of that capacity, and I seem to be having charges added to my Azure bill. You've got to be careful about that, because ultimately you've got to be looking at the usage of your capacity. If your capacity is being overused, you will have to pay back that in your future allocation, or it's going to be added to your Azure bill. Again, it's quite a big subject to get into, but yeah. So Logic Apps,
So, so,
Power
uh, yeah. Thank you, Andy. Uh, so back to you then. Please continue where you left.
Automate.
Hi Andy, welcome back. I think yeah, you can if you want you can share the screen again.
I think I dropped off, didn't I?
Yeah, there was some technical issue, so you are back now. Go ahead. And I kind of summarize what you explained to the studio. It really would depend on economy. Meaning that if you are using reserved resources, you need to take that into account and see how much are you benefiting from that. Back to you.
Still, I seem to be back again.
Yes, you are back. Go ahead.
Okay, okay, fine. So yeah, I think we've got so obviously just jump, make sure that everyone can still see and hear me. But yeah, so that feeds into the capacity planning, right? So ultimately, you've got to be finding out um, what capacity you need. What's your expected usage? And we're going to do that based on the average usage, not based on spiked usage. When we were capacity planning before in terms of on-premises servers, we're going to have to work to the biggest and largest spike. We're going to have to provision our hardware and configure our software to manage that largest spike. Fabric, we've got a concept of smoothing in which we're averaging out the workloads. So as a DBA, you're expected to look at capacity planning. So instead of looking at the spikes, you can calculate the average workload on the capacity. Okay. Now, in terms of the warehouse, what we have at the moment is that's going to equal 32 V cores. Now, this whole bursting process, there are limits. So, what happens is a fabric capacity can actually burst beyond the allocated number or the allocated compute that you have with it. Now, that's not infinite because we wouldn't really want that to happen. So, what we have is we've got these scale factors in the warehouse. So, I'm going to bring this up now. And essentially, if you're running an F2 and your workload requires bursting, it'll actually burst up to 32 times the size of that F2, an F64. After an F8, the scale factor is 12 times, right? So certain workloads are going to burst beyond the capacity's current setting, right? And then you will have to pay that capacity back later on in terms of your capacity being quiet. And that's why it's not really good practice if your capacity is bursting to then immediately pause it or reduce it in size, because ultimately you're going to pay that in terms of it being added to your Azure bill. So we're not going to stay on this slide too much because ultimately, if you watch back the recording, you can pause this, dive it into a little bit more detail. But we're looking at the right hand side. We're looking at lots of no's in the Fabric service. We can't really configure it. There's no partitioning yet. There's no indexing. The underlying storage is the index itself. Parquet files, columnar storage. Anyone familiar with SQL Server? There's an index type called column store indexing. That's by default in dedicated SQL pools. So Delta is here. There's no other form of indexes. We can't add non-clustered index. So in terms of connectivity and tools, we can use our standard SQL tools. On the left-hand side, we've got the GUI items that we can create. Lines, data sets, lake houses, machine learning models, reports. We can create folders and put those relevant items in the relevant folders. But how does that look when we connect with SQL client tools? Well, a workspace is essentially like a server. So we're going to connect to a workspace, and we're going to see our warehouses as databases. We can drill in, we can see the tables, and we can use database projects in tools like Azure Data Studio. We can't use database projects within Visual Studio and SSDT, not supported. Connecting, and we can see all our objects. So, storage. Biggest departure in terms of a proprietary service that Microsoft have created. The warehouse is working with the Delta format and storing its data within Parquet files. You can actually connect using a tool like Azure Storage Explorer with the One Lake endpoint, do anything because those are locked by the system. So it would be like being able on a seat, they're locked. You can't really do anything with them. Now, we don't have much control of the storage. There's automatic optimize and there's automatic vacuuming being performed on these tables. What that means is optimize and transforms them into larger Parquet files, which is more efficient for data retrieval and select statements. But we can actually look at the metadata of these Parquet files. If in a Spark notebook, we reference the location or the ABFSS location, which is available through the warehouse GUI, and we can use a syntax like describe detail and look at the metadata within the Parquet file. So in terms of DMVs, I'll just bring these up very quickly. I know we had some technical issues. We'll carry on. But not all DMVs that you would expect to find in SQL Server are available in the Fabric Warehouse because, hey, there's a lot of stuff there that isn't really relevant. But we have the core DMVs that are useful to show, well, how has someone connected from, who is connecting, so what are they doing? So what queries are they running? So a workspace admin, so someone that's been given Power BI or Fabric Workspace admin, they can see all the DMVs, and more importantly, they can issue a kill command, which is a standard command in any DBA toolbox to deal with queries that are either taking over the system or they need to be stopped. Now, in terms of transactions and isolation levels, the upshot is yes, transactions and isolation. We are limited to what transactions and isolation levels are supported within the Delta format, really, at the moment. And Delta, what this means, when you're reading, another session can write. When you're writing, another session can read. They aren't blocking each other. I guess that's why they call it optimistic concurrency. If I had to have a favorite isolation level, I'd probably call it optimistic. However, the locks are at the table level. There is no row locking here. So once something comes in and locks that table to do modifications, nothing can come in and modify. But you can use DM tran locks to show current locks. And ultimately what we've got is, if we're issuing a select statement on a table, then that's going to lock the table and we can't modify that table. Okay. In terms of insert, delete, update, copy into, we're going to get an intent exclusive lock on that table. And it's going to be at the table level, by the way. And lastly, if we're doing any form of data definition language, so in the warehouse, that would include. We're going to look at an update. Yes, and thanks, sure that I'm coming through okay. I think my camera is a little bit juddery here, but I'm hoping the audio is coming through okay. Of the most common way that that you would be, or you would see a transaction failing within Fabric, and that's when we have update statements. Okay, so in this example, user one started an update statement on a table. User two has started. However, user two's lucky. Their transaction committed first, even though it actually wasn't the first transaction that started on the table. Poor old user one, their update statement fails because the metadata for the table has been changed by user two. User two got there first, and user one's transaction is going to error. Okay, that's the most common. Writing, you're not going to see contention because Parquet files are immutable, so they're being written to. Now, with on forums in terms of people applying very specific row and column level security and it not being applied, it not being respected. Ultimately, at the top level, workspace level, be given admin, member, contributor. That'll give them control. That'll give them a database permissions called control, which is quite high level, very high level. If you're given viewer, you're going to be automatically given the DB data reader role for any warehouses or Lakehouse SQL endpoints that are available within that workspace. So use workspace level permissions with care. So ultimately, if we've got two, let's say we've got two warehouses in our workspace, the way that I'm going to create share the item. I don't personally agree in the GUI in terms of sharing, but that's what happens. Now, what I can do is I can share a warehouse and set no permissions. I don't give them any read or anything like that. They'll be given connection permissions. They can connect to the warehouse. I will then have to set I can assign them DB data reader. I can let them read all the data using Spark, and I can set them up permissions to be able to build reports on there. Set up your row level and column level. Just going to override the permissions. There is a report available in Fabric called the Fabric Capacity Metrics app. Little clunky, but it gives you enough information for you to understand what workloads are. So you're going to see reads and writes, and you're going to see an operation name of warehouse query or SQL endpoint query. and you'll see some capacity units being allocated against that, right? Hold that thought in terms of the capacity units. We'll also see some one lake reads and writes in terms of reading the data from Delta, writing the data from Delta that's stored in one lake. In the warehouse itself, we have some new DMVs called Query Insights. These are very, very useful DMVs. I'm going to bring them all up. Every single one of these DMVs has the SQL query that was issued against the warehouse. So you don't have to join onto another metadata table to get the SQL query. And in fact, so the audio is very shaky, so apologies for that. So in terms of the SQL query, we get the SQL query in all of these views. The two query queries, they give me some statistics in there about a query. What Fabric does is it analyzes the SQL query that's incoming, and if it's the same as a SQL query that's been run before, might be different filters. What's very important is with frequently run queries, we can actually check the average runtime of a query over time. So you can plug in Power BI, build a report to say, well, am I seeing an increase in average of my queries over time? And query insights to the capacity report that you get in Fabric. There is a column called distributed statement ID. That is the unique GUID calculation, which is a big thing. People want to understand when I'm running workloads and I've got certain capacity units being used, how can I work out a cost? I might be able, if your capacity is shared between business areas, there might be some chargeback there in terms of the usage of that capacity with different areas in the business. And what we can do is in the capacity metrics app, that's going to show you what workloads consume how many capacity units in for that workload. So let's take an example. I'm going to use a UK pay-as-you-go pricing for an. Now, if I go into my Fabric Capacity Metrics app and I see that my workload has consumed 8,000 capacity units, what I can do is I can do some calculations. Well, on an hourly basis, my F2 lets me use 7,200 capacity units. That's without bursting, okay? So I get given 7,200 capacity units per second because that F2, that two capacity, so two, three, one divided by two, I'm going to get 15 pence. And my calculation is based on how much capacity units I've used. I get to a cost. This calculation is probably a session or cost calculator. So if you search for Formu fabric costs, you'll find a blog post and you can put in your region, your capacity units, and it'll have a cost for you. But essentially, I can actually tell how much my workloads are costing via a calculation. Now, in terms of recovery, so the short answer is yes, we can recover, but there are some caveats there. Okay. First thing to understand, this is a whole warehouse recovery process. We can't cherry pick. We can't say, I need to recover this table to a specific point in time. We have manual ways of doing that because one of the benefits of Delta is that it has what's called time travel. It's essentially keeping old copies of your data as you're updating and inserting and deleting new data. So go back in time to a table and see what it was yesterday, the day before, maybe before the last load. And that's what the restore in place is doing. Is it's basically looking at these delta logs and seeing how far it can go back in time to do a restore. But we can do it either let it do it automatically or manually. Now, at the moment, that actually has been extended to 30 days availability. So instead of 7 days, we can go back 30 days in terms of being able to restore. Manually, we can create restore points. So if you're going to do a big warehouse load, if you're going to do schema changes, if you're going to do something that you think, you know what, we might need to restore back to this point. If there's any problems with what we've done, then we can create a user defined recovery point. One thing is with workspaces, workspaces can be restored if they're deleted. If you delete a warehouse, it's gone. There's no ability to restore a warehouse if it's been deleted. I hope that changes. So, in terms of source control, so the story that we have is that we can connect a workspace, houses, and connect it to Azure DevOps, connect it to a Git provider. But we're a little bit limited. We can either connect it to Azure DevOps or we can connect it to GitHub. We can't use Bitbucket, so on and so forth. We could use other Git providers if we wanted. Tool like Azure Data Studio with SQL database projects to grab that schema from the warehouse and then, well, any Git provider that you can use with Azure Data Studio, yep, sure, you can source control your database projects. One caveat that I just want to highlight with deployment pipelines is that currently, if you use deployment pipelines with the warehouse, deployment pipelines I love. Really, really deployment pipelines at this stage will delete the destination table and recreate it without the data. I hope that changes soon. Be warned. And last thing to cover really is the performance tuning aspect of the warehouse. Like I said, I'm not going to go into too much detail simply because I would just literally be parroting what's available in the documentation here. So the first thing is statistics. We're still in the world where we have statistics. The engine needs to know of the data. It runs histogram queries to understand how is data being distributed and creating the relevant statistics automatically on those tables and columns. However, if we know best, we can use manual statistics. Okay, single column statistics. I'll come to that. I'll come to that question at the end. Another option that we have that massively affects performance is an option called vorder. Now, vorder is applied in the Parquet file itself. So what Microsoft have done, Microsoft have made some further optimizations into how data is written into a Parquet file and has made it so that reading that data is more efficient, is quicker, uses less compute power. However, there is an overhead, or it takes more time and uses more capacity units when you're writing into a vOrder enabled table, because there's some extra processing that needs to happen to further optimize the Parquet file. What we can do is we can disable that vOrdering. So if our workload dictates that actually we're doing more writing into the warehouse than we are reading, it might make sense to disable vOrder in its entirety. I would love vOrder on a table by table basis within the warehouse. Hopefully, we'll see that soon. There's probably an idea. If it's not, I'm going to go and create it right now after this session. However, once you disable vOrder, you can't re-enable it. It's a one-way operation at the moment. Lake houses, you can set vOrdering on specific tables. So if you have staging tables in a lake house and you're loading with Spark, hey, you can decide, hey, I'm going to set vOrdering off for those tables because it's only transient data that's going off to a destination anyway. I don't need it vOrdered. So you've got more control over it in the lake house. Going back to the usage of the warehouse service itself, the clue's in the name. It's a warehouse service. Trickle inserts, tiny little modifications, single row inserts, single row updates, and single row deletes will not make the warehouse very happy. This is a batch insert process. When data is modified or written in Delta, existing Parquet files are not revisited and updated. New Parquet files are created. It's an append only process. And what the engine has to do under the hood is it's going to have to look and probably see all of these millions and millions and millions of tiny little Parquet files that have been created because of all these trickle inserts. And it's going to have to compact them up into larger Parquet files. Performance is going to suffer when you're reading before it does this maintenance. And again, look, we're still in a world of choosing data types for columns. Now, obviously, there's a complication in terms of precision within Parquet files. Parquet files don't really care that a column is defined as a varchar 50 or a varchar 500 or a varchar 4000. Delta does, and a SQL engine does, because it will provision the required amount of compute to deal with the data types that it thinks it's going to have to deal with. So, for example, if all your columns are varchar 8000, well, the engine's going to provision the compute to deal with the fact it might have to process varchar 8000. So, again, choose the most appropriate data types for your data. And they're available on the warehouse performance guidelines documents. It goes into some detail about, co-locating data and things like that. Again, I don't want to parrot what's in that document, but these are the four most important things that I always look at in terms of performance tuning. And the last thing is to understand the warehouse service in Fabric, regardless of whether you're administrating it, looking after it, developing for it, even using it as an analyst to query. If time permits, and we're all busy people, right? We're all trying to fit in learning around work. Read up about Delta. Go to the OSS Delta Lake website. Have a look at the documentation and just have a read and understand what Delta is and what it does. Because ultimately, what the Fabric Warehouse can do and not do in the warehouse service. So with that, I'm going to say thank you.
Thank you, Andy. I hope you can hear me. So sometimes audio come and go. I believe there was some audio issues, but overall it came back. Probably some connectivity stuff. But thank you for presentation. Um, I believe Olivier asked a question earlier about backing up. Um, in, does the backing up include SQL queries stored in the warehouse? And you already answered that, correct? Can you hear us, Andy?
You
We
still hear me
don't.
okay?
Now your audio came back a little bit. Can you speak?
Okay, okay. The SQL queries that are stored within the shared queries
Right.
section, as long as the warehouse exists, you're going to lose those SQL queries, not just objects that exist within the Fabric service themselves.
Mm-hmm.
So,
Uh, yeah,
yeah.
yeah. Andy, can you repeat what
So
you
it's,
said
yeah.
because
So
your audio
essentially,
game
it's my
broke
audio.
up.
So
Yeah, back
yeah,
up.
we're going to have to check whether whether when the warehouse is connected via Git in the workspace, whether those SQL queries are actually stored. I can't quite remember if that's the case. But yes, I would definitely take those queries and store them elsewhere, because if anything happens to that warehouse service, all those queries are going to be gone.
Okay. All right. I hope that answers your question, Oliver. Thank you for the question there. Andy, thank you for very, informative and interesting session on Microsoft Fabric warehouses from DBA perspective, especially you diving into some cost and performance related matters that not widely maybe known across the community. And before, saying, before finishing our session, where you would like our viewers to go to get connected with you and get more information about this topic.
So what I would say is, if I just
Okay.
go back to my slide here.
Mm-hmm.
So essentially, if you go to serverlesssql.com, that's basically where I'm blogging most on Fabric, and there'll be links to official Fabric documentation to look up. But the main body of content, if you just search for Microsoft Fabric warehouse documentation, it'll take you to the warehouse documentation, and you'll be able to work through examples. It'll show you recommended practices. It'll talk about the engine, and it goes into quite a lot of detail about monitoring as well. So everything is there that you need in that Microsoft documentation.
Great. Thank you. All right, everyone. Thank you again, Andy, for your presentation. We had good interaction here at the chat, and we had some questions that I brought to the studio. Uh, I think there was a little bit audio issue here and there from technical perspective, but over time it
Apologies.
kind of yeah smooths it out and start to go better. But for anyone who will be watching this session later on, it's going to be on our Cloud Launch Only YouTube channel. And Andy provided his contact information here if you wanna read more about this topic and get in touch with him. Again, thank you, Andy. Any last kind of minute words, suggestions, or advice from you to our to our viewers here?
So one of the things you've got a question, go on there. people like myself, you're going to get all the help you
All right. I think there was again some audio kind of coming back and goes, but again, thank you, Andy, very much for your presentation. Our viewers will go and contact you from the information that you have on this slide. Thank you, everyone, for watching
please.
us and putting the questions there. Have a great day. Thank you, everyone. Take care. Bye. Thanks, Andy.
Thank you.